Sometimes you're going to encounter inequality problems that have absolute values in them, and these need to be treated a little bit differently. So when you have an absolute value in an inequality, just like if you had an absolute value in an equation, you really are talking about two separate pieces that combine to form your entire function. So let's, for example, say we had something the absolute value of x minus 4 is greater than 5. So remember that the absolute value always makes the number in there positive. So let's just do a quick couple of examples to see what types of numbers that could work here. Well, clearly what's inside the absolute value could just be greater than 5, like it could be 8 or 100 or something like that. And then the absolute value of that would certainly still be greater than 5. But it could be a negative number that's large enough too, so it could be negative 8 or negative 100, and if you took the absolute value of that, you would get something that's greater than 5 also. So what we need to break this down into should seem pretty logical once you've gone through those examples that we just talked about. Either x minus 4 itself is just greater than 5, or x minus 4 is less than negative 5. So it could be a number that's more negative than negative 5, or it could be a number that's bigger, more positive than positive 5, and either of these things would work. So now let's solve these inequalities. Well, all we need to do is add 4 to each one. So this gives you x is greater than 9. Over here, if we add 4, we get x is less than negative 1. So both of these ranges are correct for this. So again, if we were to write this on a number line, we would have 9 here, negative 1 here. These are strict inequalities in this case, so both of these are going to be open circles. And we could have anything greater than 9, or we could have anything less than negative 1. But not negative 1 or 9 themselves, or anything in between. So whenever you have an absolute value in an inequality, you always want to break it into its two cases. Now keep in mind, there are going to be tricky things too, where you actually don't even need to do any work. Let's look at an example of that. If you had a problem like this come up, you actually don't need to do anything for this problem, because keep in mind what absolute value means. Absolute value always makes anything positive. So no matter what it's in here, the absolute value is going to make it positive. And no matter what that is, it's always going to be greater than negative 1. So just by looking at this, you could say, in interval notation, the solution to this is all real numbers, negative infinity to infinity. Because no matter what you have in an absolute value, it's always going to be greater than negative 1. Similarly, if you had something like this, is less than 0, right away you could say that that is impossible, because the absolute value of anything cannot be less than 0. So you would have no solution to this. And you didn't have to break it down into its pieces and figure out anything. These you could do clearly just by looking at it. So always beware that your problem on a test or something might be one of these, where the problem's a lot simpler than you think. Otherwise, you need to break it into its two parts and solve both inequalities simultaneously.